Okay, the formula for the velocity is going to be v is equal to v0 plus at. Now again, we have no velocity in the x direction. I'm sorry, no acceleration in the x direction, so that the initial x velocity will be the velocity at all time. Okay, now I want to copy this and paste it all the way down here. I can copy, Command or Control C, and then Shift, click at the bottom to select the whole column, and then Command or Control V to paste the values. And it's done. The x velocity is constant. Instead, however, I'm going to show you another little shortcut. I'm going to do a Control Z to undo what I just did. This scrolled for some reason. I'm going to select this column or this cell again, and instead of copy paste like I did before, I'm going to double click on this lower right corner. And by doing that, Excel automatically fills only as far as the adjacent column is filled. So it automatically stopped at the bottom of that column. That's a very convenient shortcut. Okay, now the y equation is going to look like the x equation. Double click to set the column width. I just have to change all these x's to y's. I'm not going to worry about that right now. So y is equal to, the initial y is equal to y0 plus vy, which is this value, times time, which is this value, plus 0.5 times the acceleration in the y direction, which is a negative value as it's entered in the cell here, times the time squared. And for Excel to square something, to raise something to a power, use the caret symbol, which is on the keyboard, hold the shift key down and press the number 6. I'm going to go back and enter my dollar signs where needed. I think that should do it. And I'll double click to bring it all the way down. Velocity in y direction looks like the velocity in the x direction formula that we wrote up here. So it's be equal to the initial velocity plus the acceleration in the y direction. This time we have an acceleration, a non-zero acceleration, times the time. And let's not forget to put the dollar signs in the appropriate places here, the appropriate cell references, so that those values are locked. Double click to clone it down. And there we have it. Let's plot this and see what it looks like. To do that, I'm going to select the whole table. The way I select the table is I start at the upper left, click, then move to the lower right, press and hold the shift key, click again. Now I've got the whole table. I could also start at the lower right, move my mouse to the top, press shift and hold, and click again. The advantage of doing it this way is that since I selected the upper window last, that is I started from the lower right and went to the upper left, when I insert the chart, it'll be in the upper window. If I go the other way, selecting upper left first, lower right, then the chart will end up in the lower window. It doesn't really matter because you can always move the chart around. What I'm going to do now is plot x, v sub x, y, and v sub y all as a function of time. To do that, I'm going to insert a chart. One way I can do that is in the Insert menu, go to Chart. And the ellipsis after the word chart means that there is another menu coming up. I have a choice of charts to pick. Sorry, I've selected too much in my... There we go. Okay, I have many charts to choose from. Notice this line chart type. This is very tempting, but don't be misled by this. This is going to plot all these columns as a function of the number of the row, and that's not what we're after. Instead, we want something called XY scatter, and now we have several choices for that. I'm going to choose a type without markers, but connecting the dots rather than smoothing. So this is the one I typically would use. And automatically, when I selected the table region in the spreadsheet, I included the headings. Those labels then automatically appeared on the right here. Unfortunately, the formatting doesn't carry through. That is, the subscripts that we've carefully entered here did not carry through here. Okay, but we can see X is this line here. The X position is changing linearly with time, increasing in a positive manner, as we would expect for a constant X velocity. The velocity in the X direction, however, is constant, horizontal line. The Y velocity is constantly decreasing because there's a constant rate of change in Y velocity, constant acceleration in the Y direction. And the Y position is parabolic, shown by this line here. Okay. Suppose I wanted to plot the Y position as a function of the X position. Let me show you how to do that. I'm going to select the X column by clicking on the heading, move the mouse to the bottom, press and hold Shift key, click. Now I'm going to go to the top of the Y column. If I press and hold Shift key, I'm going to select everything in between. I don't want to do that. Instead, I'm going to press and hold the Command key, Control key on a PC. Now notice when I did that, this column still is selected. I've also selected this cell. Now I'm going to go down to the bottom of that column, press the Shift key, click. Now I've selected two columns that aren't next to each other. I'm going to insert chart again. Again, choosing the XY scatter. And now we have a plot of Y versus X. I'll move my boundary up a little bit so we can see it. Now keep in mind that this parabolic line here is Y versus T. This parabolic line is Y versus X. But X and T are related by that constant X velocity. So that's why they both are parabolic in behavior. Okay, let me get this chart out of the way. I'll simply delete it for now. And likewise with this chart.